Hello everyone, I'm Aylin. Just like every Thursday, we are here again this week with a new topic, which is the factors affecting detector installation according to EN 5414. In today's webinar, we'll take a general look at the design of fire protection systems in accordance with the EN 54-14 standard, which was last updated in 2018. We'll talk about what needs to be considered during the installation process, the key factors that can affect system performance, and the precautions that should be taken to ensure the system works reliably and effectively. The topics we will cover include detector installation on flat ceilings, the effect of ceiling irregularities on detector installation, and detector installation in suspended ceilings. We will also look at detector installation in raised floors, as well as how smoke clouds accumulate below the ceiling and how this affects detection. In addition, we will examine the impact of walls or partitions on detector placement, detector installation in ventilation ducts, and the effect of airflow on detector installation and performance. So, detector installation in flat horizontal ceilings, in general the performance of heat and smoke detectors depends on having a ceiling above them, since smoke and heat tend to rise and collect there. Because of this, detectors should usually be installed close to the ceiling, with their sensitive parts positioned about 25 mm below it and within the top 10% of the room height. At the same time, detectors shouldn't be mounted too far down from the ceiling. For smoke detectors in particular, they should not be installed more than 600 mm below the ceiling. This placement helps ensure the detectors can respond quickly and effectively when smoke or heat begins to accumulate. However, heat detectors should not be installed too far below the ceiling. Specifically, they should not be mounted more than 115 mm below it. Proper placement in this area helps ensure that detectors can respond quickly when heat or smoke begins to accumulate. Also. So, the effect of ceiling irregularities. This arrangement applies to ceilings that have beam structures or similar irregular shapes. In these cases, the total height of the room should be taken into account when planning detector placement. If the depth of the ceiling irregularities is less than 10% of the ceiling height, the ceiling can generally be treated as flat, and the radius limits specified in section 6.5.2 should be applied for detector spacing. For example, if we have a room height of 3 meters, beams with a depth of up to 29 cm can be ignored, and the detectors can be installed as if the ceiling were flat. When doing this, the detectors should not be mounted directly on the beams, but rather placed in the spaces between the beams. If the beam depth is greater than 10% of the total room height, the ceiling is no longer considered flat and is treated as an irregular ceiling. In this case, the ceiling creates a cell or pool-like layout between the beams, as you can see. For example, imagine a room with a ceiling height of 3 meters and a beam depth of 35 cm. Since the beam depth exceeds 10% of the room height, the ceiling must be treated as an irregular one. The question then becomes, should we place a detector in every cell between the beams, or should we skip some cells? There is a calculation for this defined by the standard. First, the distance between two beams measured from edge to edge should be determined and defined as capital D. Then the difference between the total room height is capital H, and the beam depth is smaller h, is calculated. According to the standard, if the distance d is greater than 25% of the difference, a detector should be installed in every cell between the beams. If D is smaller than 25% of the difference, detectors can be installed at alternating cells. For instance, if D is 2.5 meter and 25% of the difference is 2.3 meter, then detectors should be placed in one cell and skipped in the next, continuing in this alternating pattern. Then if the distance D between the beams is less than 13% of the difference, then detectors do not need to be placed in every second cell. Instead, the standard states that a detector should be installed in every third cell. In practice, this means placing a detector in one cell, skipping the next two cells, and then placing the detector in the third cell, continuing in this pattern. This rule helps determine how detectors should be arranged on irregular ceilings with beams, ensuring proper coverage while avoiding unnecessary detector installations. There are also cases involving flat ceilings and sloped ceilings. So how do we distinguish between these two? The standard explains this quite clearly. It defines h and the vertical distance between the highest point of the roof and the ceiling level. If this h distance is less than 60 cm, the slope can be ignored and the ceiling can be treated as flat ceiling. To make it simpler, if the height difference is less than 60 cm, the ceiling is considered flat and detectors can be installed using standard flat ceiling layout. However, if the distance between the highest point of the roof and the ceiling exceeds 60 cm, the ceiling is considered sloped. In that case, detectors should be installed at the peak of the roof as well as along the slope sections to ensure proper smoke detection. Another common situation is suspended ceilings, and deciding whether to install detectors inside them can often be confusing. The key question is, should we install detectors inside the suspended ceiling or not? According to the standard, the decision depends on whether there is a fire risk inside the ceiling void. For example, if cables pass through the space above the suspended ceiling, this can create a potential fire risk. If such a risk exists, then fire detection is also required inside the ceiling void. To determine this, we first look at whether the cables inside the suspended ceiling are fire resistant. If the cables are fire resistant, a detector must be installed inside the suspended ceiling when a fire load exceeds 25 MJ. If the cables are not fire resistant, detectors must be installed when the fire load exceeds 15 MJ. Since detectors installed in the suspended ceiling will remain hidden once the ceiling panels are closed, it must still be possible to identify them from outside. For this reason, a remote indicator should be installed outside the suspended ceiling and connected to the detector. This indicator helps us locate the detector and understand its status. When the detector is operating normally, the indicator will flash periodically, showing that the detector is being pulled by the system. If the detector goes into alarm, the indicator lamp will light continuously, indicating both the alarm condition and the physical location of the detector inside the suspended ceiling. So in summary, the decision to install detectors in suspended ceilings depends on whether there is a fire risk in the ceiling void and on the fire load of the cables present in that space. Now let's look at the areas below raised floors. Similar to suspended ceilings, if there is a fire risk under the raised floor, detectors should also be installed in this space. However, detectors should not be mounted directly to the floor surface because during maintenance work or renovations they may be damaged by pressure or by people stepping on the floor panels. Instead, detectors are typically positioned in the middle of the void space, often mounted using EMT conduits so that they can remain exposed and protected within the raised floor area. The standard also provides guidance on when detection is required in these voids. Detectors should be installed under raised floors if a fire could grow large or allow smoke to spread outside the void before it is detected by detectors outside the space, or if a fire inside the void could damage emergency system cables before being detected. The key point here is to avoid mounting the detector directly on the base surface. Instead, it should be installed within the middle of the void, where it is less likely to be damaged during maintenance or by structural pressure from the raised flooring system. Now let's look at the detector placement near walls, partitions, and obstacles. The areas where we installed detectors are not always perfectly open or uniform. Sometimes there are walls, partitions, or other obstacles that can affect how detectors should be positioned. So how do we decide where to place them? First, there is a general rule that applies to all types of detectors, whether they are heat, smoke, or multi-sensor detectors. For a detector to operate properly, there must be at least 50 cm of clear space around it. This means 50 cm of clearance on the right, left, and below the detector, ensuring that smoke or heat can reach the detector without obstruction. There are also situations where partitions are present. If a partition extends from the floor all the way to the ceiling, the detector must be installed so that there is at least 50 cm of distance between the detector and the partition. However, sometimes a partition does not extend all the way to the ceiling. It may stop at a certain height. In these cases, the standard provides a clear guideline. You should look at the distance between the top of the partition and the ceiling. If the gap between the partition and the ceiling is less than 30 cm, the partition should be treated as if it extends all the way to the ceiling, and you should still maintain a 50 cm distance between the detector and the partition. But if the gap is greater than 30 cm, the partition can generally be ignored, and the detector can be installed according to the standard detector layout rules. This approach ensures that obstacles do not interfere with the natural movement of smoke or heat, and allowing the detector to respond quickly and reliably. Let's also talk about detector installation in ventilation ducts. Why is it important to use detectors in ventilation ducts? It's important because ventilation systems move air from one place to another, and if a fire occurs, smoke can be transported through these ducts before it reaches the detectors inside the room. For example, imagine in a room where a ventilation system is extracting contaminated air to maintain air circulation. If a fire starts near the air extraction point, the smoke may be pulled directly into the ventilation duct. In this case, the smoke might not reach the standard room detector immediately, because it is being drawn into the duct system. During this delay, the fire could continue to grow. For this reason, the air moving through ventilation ducts also needs to be monitored for smoke. We need to check whether the air being transported contains smoke from a potential fire. To do this, we use a device called a duct sampling detector. These detectors are installed on the outside of the ventilation duct. Inside the detector housing, there's a smoke detector, and connected to it it's a sampling pipe that extends into the duct. This pipe has small holes along its length. As air flows through the duct, a portion of that air enters the pipe through these holes and is carried out to the detector housing. The smoke detector then analyzes the sampled air to determine whether smoke is present. If smoke is detected, the detector triggers an alarm. If not, the air continues to flow normally through the duct. Now, where should these detectors be installed? The first location is at points where the airflow direction changes, such as after a bend in the duct. For example, when the airflow moves horizontally and then changes direction at a corner, like there. The detector should be installed on the straight section following that bend, and the installation distance should be 3 times the width of the air duct. For instance, if the duct width is 2 meters, the detector should be installed approximately 6 meters after the direction change. The second important location is where air enters the duct system, such as near ventilation grills or intake points. Even if the air already flowing through the duct is clean, smoke could enter the system from these intake points. Therefore, another sampling detector should be installed at a distance of 3 times the duct width from the air entry point. This is the basic principle behind detector placement in ventilation ducts, ensuring that smoke carried through the ventilation system can be detected as early as possible. So another important factor is the effect of airflow on detector installation. When placing the detectors near ventilation outlets, air conditioning units, or air vents, we need to ensure that the airflow does not interfere with the detector's operation. Strong air movement can delay, dilute, or redirect smoke, which may prevent the detector from detecting smoke quickly and accurately. To avoid this problem and ensure stable operation, detectors should be installed at least 0.5 meters away from ventilation grills or air conditioning outlets. It is also important to note that these placement rules do not apply to only specific type of a detector. The guidelines we have discussed apply to all type of detectors, including heat detectors, smoke detectors, and also multi-sensor detectors. These rules are intended to ensure that detectors function reliably and effectively, regardless of the detector type used. Finally, there is a new clause added to the EN 54-14 standard. The EN 54 standard was revised in 2018, and with this revision, a requirement related to device identification was introduced. This clause essentially means that the control and indicating equipment may be capable of individually identifying the detector or manual call point that triggered the alarm. When this feature is used, there must be a method to ensure that information displayed on the panel can be clearly linked to corresponding detector or call point in the field. To achieve this, if detector labels are used to establish the relationship between detectors or manual call points and the control panel, the identification numbers or letters must be added to the detectors and manual call points. These identifiers must match the information shown on the control panel display. In practice, this refers to the use of numbering labels. According to the updated version of this standard, addressable detectors and manual call points should be labeled with identifiers that indicate their system address. The number shown on the label in the field must match the number displayed on the fire alarm panel. For example, if a detector is defined as device 1 on the panel, the label attached to the detector in the field should also show 1. If another detector is defined as device 2, the label in the field should show 2 as well. At the moment, the numbering requirement is mandatory for detectors and manual call panes, while it is not yet strictly required for other equipment. However, in practical installations, many professionals choose to label all field devices in this way, as it makes system identification, maintenance, and troubleshooting much easier. So that's all for today. Thank you for your participation. Next week, we will be talking about Modbus communication protocol in fire systems. See you next Thursday at 11 a.m.